What's up, everybody? So, for today's lesson, we're going to finish up the section on ellipses. I got three problems I want to show you. The first one is translation of ellipses. We did this in second period, but not in first. So if you feel good on this in second period, you can skip ahead to the next part of the video, or you can rewatch this and just get a teaching on translations. So if we start out with our ellipse equation here as x squared over a squared plus y squared over b squared equals 1, right? It's got to equal 1. We see that our horizontal axis is our major axis because the ellipse looks more flattened going this way. We know a squared has to be under x squared. Okay, cool. So that all checks out. Now, what happens if we take this ellipse and we shift it over h and up k? Because we can do that with ellipses and shapes. We can translate them, slide them over and up. Well, that's going to give us a new equation of an ellipse that's going to look like this. So this equation right here is going to be the translated ellipse. So we see the difference is that here we have the x minus h and y minus k. So what that's going to mean is that the new center is going to be this h comma k. So the center gets shifted over h and up k, becomes h comma k of our new ellipse. So how does that work in terms of a problem? Well, let's look at one and we'll figure out how we're going to translate an ellipse in terms of the problem here. So we've got checkpoint 4 here. It says x plus 1 squared divided by 9 plus y minus 2 squared divided by 4 equals 1. And the question is, where are the foci located? So just a reminder, foci, the letter that stands for foci was our C term. And we're going to use that equation, c squared equals a squared minus b squared, in order to solve for that. But we also have to take into account the translation. So we have x plus 1 and y minus 2. This plus 1, remember, plus 1 implies we're translating it to the left because we're adding 1. We go the opposite direction of this sign. So this is going to be a left shift of 1. And this minus 2 is going to be a downward shift of 2. I said downward, I meant to say upward. We go the opposite direction. Negative implies down, so we go opposite, and that's going to be upward shift of 2. So what that means is that our new center, instead of being at the origin, is going to go over 1 and up 2. So that's going to be our new center of the actual ellipse. So what I want to do is I want to graph my values in terms of my two axes. So, sorry, my major axis and my minor axis. 9 is bigger than 4. Therefore, x is going to be my major axis. So, but I have to remember this is my new origin. So this is going to be my major axis right here that goes through the origin. And this is my minor. All right, so now I've got that sorted out. And now what I need to do is I need to figure out a and b. Well, a squared is equal to this one right here, and that's going to be 9. Therefore, a is equal to 3. And b squared is my other value, which is equal to 4. So b is equal to 2. So now that tells us if a is 3, that goes on the major axis. Let me just redraw this because I got it a little cluttered up there. It's hard to see the lines. So my major axis is going through right here. So now with 3, that means it's 3 units away from the new origin. So I'm going to go 1, 2, and 3 units right there. And then 1, 2, and 3 units this way. Now my minor axis is going to be B. And that's going to go 2 up, 1, 2 there. And then 2 down right there. Okay, so now I have my general idea of what the ellipse is going to look like after it's been translated. I still haven't answered the question, though, because the question says, where are the foci located? So how do we do that? Well, let's think about that in terms of our original equation. If, just like we solved for A and B, we can solve for C and then translate those points. So let's go ahead and do that. C squared is equal to A squared is 9 minus B squared, which is 4. So C squared is equal to 5. Therefore, c is equal to root 5. So what does that mean? Well, remember, c is also on the major axis. And root 5 is about 2.1. So if c is on the major axis, it's going to be here, and it's 2.1 units away from the origin. So we go here from -1, we go over 1, and then 2.1. So it's right there. That's our foci. And then here we go 1 and 2.1 right there. So what I have to do is now I have to figure out where this point is, because that's the question, where are the foci located? So here, if I go over, I go to 0, and then 1, and another 0.1. So that point right there is going to be 1.1 comma 2 units high. So that's where one of my foci is located. The other one comes from here, and I have to move to the left 2.1. So I go from -1, where I'm at -1, -2, -3, and then another 0.1. So that's going to be -3.1 comma 2 units high. And that is the answer, because those are where my two foci are located. Translating ellipses. Okay. Next one, 2 out of 3. Did I say 2 problems? We're doing 3. Now, in this situation, we are going to have this equation right here, and we're told that it's an ellipse, but it doesn't look like the equation of ellipse. So what we're going to do is we need to complete the square on both x and y. So we're going to have to rearrange our terms so that the x terms are arranged in descending order, the y terms are arranged in descending order, and the constant term appears on the right. When it says on the right, what it means on the right of the equal sign. Okay. So let's go ahead and rearrange our terms so that we have x terms arranged in descending order. My x terms are going to be 9x squared minus 18x. And I'll cross those out to make sure I don't reuse them. Plus my y terms arranged in descending order, 4y squared, 16y. Okay. And then the constant term appears on the right of the equation. So that's going to be equals. This is a -11. I add it over to the right side there. All right. So now I have organized my terms. And now what I need to do is complete the square for each of these. But before I do that, you know that I don't like working with complicated numbers. So I am going to try to make these simpler. And I can do that by factoring out the 9. And factoring out the 4. Okay, so now what I need to do is complete the square on the inside term. So we've got 9 times x squared minus 2x plus something plus 4 times y squared plus 4y plus something equals 11. Now, to complete the square, I have to make this thing in here a perfect square trinomial. How do we do that? Well, we look at the b value, in this case, -2, and we take half of that and then square it. So again, this term here is going to be b divided by 2 and then squared. So -2 divided by 2 is 1. We square it, and then we get a +1 there. Now, we have to keep our whole equation balanced on the left and the right side. In this case, we added 1, which is going to be multiplied by this 9. So that means we're adding 9 to this side of the equation, which means we also have to add 9 to the right side of the equation so that it's balanced. Let's complete the square for the y's. Y squared plus 4y plus something is going to make a perfect square trinomial. Take half of this number and square it. Half of 4 is 2. 2 squared is 4. We add 4 inside the parentheses. 4 times this 4 is going to be 16 that we're adding to the left side. So we have to add 16 to the right side. All right. Now we need to factor. So we have 9. And this factors into x minus x minus 1 squared plus 4 times y plus 2 squared equals, and these all add up to 36. So now we're getting a little bit closer to our equation of an ellipse. This side has to be 1, So I divide the whole equation by 36. And that's going to give me 9 divided by 36 becomes 4 quantity x minus 1 squared. No, sorry. Over 4, right? 9/36 is 4. Plus 4 divided by 36, which is y plus 2 squared divided by 9 equals 1. 36 over 36 is just 1. This is our equation of the parabola. I said parabola, ellipse, the equation of the ellipse. It's translated 1 unit to the right and 2 units down. Okay. Our last problem is going to be an application problem. So in this situation, we have a semi-elliptical archway. What that means is just like, it's not a semicircle, it's just half of an ellipse. It's a semi-ellipse over a one-way road, and it's got a height of 10 feet and a width of 40 feet. So we know that the maximum height of the ellipse, this A value here, sorry, B value, because that's the minor axis, is going to be 10 feet, and the width is 40 feet. Therefore, from the center to the edge, our A value is going to be equal to 20 feet. All right, A equals 20, because that's our major axis, and B equals 10, because that's our minor axis. Right, the distance from the center to the edge of the ellipse is 10. Okay, now your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of the archway? This is a very financially important question because we don't want to destroy our truck. So if we look at this diagram down here, this is our semi-elliptical tunnel and the truck going through it. So now we know that if we split the truck down the middle, the truck is 10 feet wide, that each side of the truck is 5 feet. So we know that because the tunnel is 10 feet tall at the intersection point of the minor axis, the truck will definitely go through there. But we're concerned about whether or not, as the ellipse curves down, will the 9-foot tall truck smash into the top of the tunnel 5 feet away from the center. And this implies that the trucker knows how to drive exactly down the center of a road for the entirety of the tunnel. So we need to figure out the height of the ellipse 5 feet from the center. Okay. So first off, first thing we need to do is we need to come up with our equation of this particular ellipse. So let's see what we can get here. X squared over plus y squared over equals 1. Now, I didn't write A or B here because I'm trying to figure out which is which. All right, now X is the long side, so that's going to be my major axis, and Y is going to be my minor. That means that X squared goes over A squared and Y squared goes over B squared. Okay. So this is our standard form of the equation of an ellipse. And we know that A is 20. So X squared over 20 squared plus Y squared over 10 squared equals 1. X squared over 400 plus Y squared over 10 or 100, pardon me, equals 1. All right, cool. So that is the equation of this ellipse. So now what we need to do is we want to know what y equals the height of the tunnel, this y value here, at 5 feet away from the center of the tunnel. So 5 is going to be our new x value because we're translating it over, we're sliding over x. We want to know how far 5. If we go over 5, what is y going to be? So I'm going to plug 5 in here. And now I'm going to solve for y. So 25 over 400 plus y squared over 100 equals 1. You know that I try to clear my fractions whenever I can. So my common denominator here is going to be 400. That's going to cancel this out. 400 over 100 right? So I have 25 plus 400 y squared over 100 equals 400 times 1 is 400. 400 over 100 is going to reduce to 4. So I get 25 plus 4y squared equals 400. Subtract 25. Coming up here, 4y squared equals 375. Divide by 4. Y squared equals 375 divided by 4. It doesn't go unevenly. Square root both sides. Y is approximately, if I do this math on my calculator, it's going to be 9.68 feet. So that tells me that at 5 feet away from the center, the height is 9.68 feet. So yes, if I drive carefully, the truck will fit. Yay. Okay, thank you for that. Sorry I couldn't be there today. Please finish up your Math Excel. It is due Sunday at midnight. I will see you Monday.